Alright, I'm going to go through this problem about sharks, and this problem is actually going to go through a lot of different content that we have covered so far this school year, and it's going to help us with the problems that we have to do for this week. So we are focusing on, remember, z-scores, the standard normal curve, which we call that a normal distribution. So this problem is not on any of your homework problems. I just chose this problem because it goes through a lot of the things that you're going to need for your homework. So it says, here are the lengths in feet of 44 great white sharks. And then it gives you the data. So A says, enter these data into your calculator and make a histogram. Include a sketch of the graph on your paper. Then calculate one variable statistics. Describe the shape, center, and spread of the distribution of shark lengths. So I'm actually going to enter this into the data, and I'm going to make, I'm going to show you a video of that data within this video so that you know how to make a histogram on your calculator. Okay, so I've added a video for us of what it looks like on our calculator, so I'm going to play that now. Okay, so I have already placed the data into the calculator. So remember, to do that, if I were just on a regular screen, I would go to Stat, and then number 1 for Edit. And so I've already taken the time to put all of the numbers of our data into L1, going straight down in L1. Okay, now it says though that I need to make a histogram. So to make a histogram on your calculator, we are actually going to go to second and the y equals button, which is stat plot. And so here you might see a lot of different things. So first, in number 1, so I want to hit enter. And I want to make sure that stat plot 1 is on, and it is. If it's not, you just hit enter to the on button. You can just arrow over to it. Now I need to go down to type. So the first type there you see is a scatter plot, we have a line graph, now we have a histogram, there are box plots down there, and like a normal distribution plot. So we want a histogram. The list though, however, is not L4. My list is in L1, so to change it I hit the second button and then the number 1 to change it to L1. And we'll leave the frequency at 1. And I'm going to hit enter. Oh, I guess that doesn't do anything. I'm not going to hit enter. I'm actually going to hit zoom, or, well, we can hit graph. So right now you see that I don't see anything when I hit graph. So what I have to do is do a zoom, and then if you scroll down, you'll see that zoom stat is actually number 9. So I'm going to hit number 9, and now you can see our nice lovely histogram. If you wanted to draw this histogram, what you could do is hit the trace button, and now for every bar, I know 9.4 is where my bar line starts for this first bar, and it ends at 11.6. And it tells me that the frequency of this bar is 1. Because remember, it's a histogram, and so histograms tell us frequencies. We go to the next bar, again 11.6, and then it says my max is 13.8, and there are 13 pieces of data there. 13.8 to 16.1, there's 10. 16.1 to 18.3, and there's 14 pieces of data, so on and so forth. So if I want to draw it now, I can do that by looking at this and then drawing the picture on the graph. If you want, you can just do this on your calculator and just take a picture of this and then just add it into your Word document that you're submitting. Or you can redraw it on notebook paper. Right, so now that we have that, we are going to then, it says, for the next one, we're going to have to find out what our one variable statistics are. So if I go back to stat, and I go to calculate 1 And that says my list is L5, so I'm going to change it back to L1. My frequency, and then I'm going to calculate. I leave my frequency list blank, hit calculate. So now I know that my mean is 15.58, or 59, I guess, if we round. My standard deviation is 2.55 if we round. So I'm going to write that down, and then we can continue doing the problems from there. So that's how you do it on your calculator. Okay, so in the first problem, it also asks to describe the shape, center, and spread of the distribution of the shark length. So if I actually go to the video, whoops, that's not what I wanted to do. And if I rewind it to where we can see the distribution now. So I'm looking at the shape and spread, and I can say that if I draw on top of this, it kind of resembles a symmetric histogram a little bit. I mean, there is a gap, but I mean, we don't have a whole lot of data either, so it's as close as we're going to get to a symmetric histogram for as little data as we have. So that's what I would say for the spread, the shape, and the center is going to be, looks like it's around, let's see what that number is if I rewind some more for where the middle is. Looks like it's between the 16 and 18 mark for the center. So it's going to be like the mean, yeah, close to the mean, which is 15.59, which we just wrote down. All right, so now it says calculate the percent of observations that fall within 1, 2, and 3 standard deviations of the mean, and how do these compare with the 68, 95, 99.7 rule. Okay, so percent of observations that fall within. So basically what they want to know is, without even looking at data, we just know that we have 44 sharks, 44 great white sharks. And so we're going to try to figure out what is the 68% rule, like how many great white sharks of data do we have to have. So all I'm going to do in my calculator is some simple math. I'm just going to take 44, and I'm actually going to multiply by 0.68 to see how much of the data we would have. So it says 29.92. So I can't have actually 29.92 sharks. So if I go less than that and I say 29 divided by 44, that gives me 65.9%. If I do 30 divided by 44, that gives me 68.1. So that's over, that's too much. So I can't do that. So I'm actually going to say that for the first one, so this was for A that we did, and so now I'm going to do B. So it looks like for 68%, it's actually 29 over 44, which gives us about 65.9. So I need 29 pieces of data to get me as close to 68% as possible. So I'm going to do the same thing, 44 times 0.95. That tells me 41.8. So if I take 41 divided by 44, that gives me 93. If I take 42 divided by 44, that gives me 95.4. We don't want to go over, so I'm going to say that the next one is 41 divided by 44, which gives us 93, and I'll round it to 2. And then for the last one, as close as I could get to 99.7. So 43 divided by 44, that gives us 97. I mean, I would say that that's probably as close as we're gonna get, unless we did 44, which would be 100%. So 43 divided by 44 equals 97.7. All right, so now it says, how do these results compare to the 68, 95, 97 rule? So they are pretty close if we were going to actually figure out how much data fits within there. They are pretty close to the amount of data, and we could figure out what the numbers were and everything. So for C, it says use your calculator to construct a normal probability plot. Include a sketch of the graph on your paper. Interpret this plot. All right, so to construct a normal probability plot on your calculator, I'm gonna need to make another video. So let me actually shrink this video down. Well, I guess those numbers are gonna follow it. Okay, it's weird. All right, so there's that, and I'm gonna make another video. So now I'm gonna play the video that I just made. Okay, so now what we need is to make a, what did it say? A normal probability plot. All right, so here's what we do for that. So I'm going to go back to my stat plot. And so here's the same stuff we just had in. So I'm going to hit enter. All right, so our plot one's on. And it was, the type was a histogram. If you keep going to the right though, it'll move down to the other one. What we want is the one on the very end. Hit enter. This is going to be showing whether we can assume that this is a normal probability or not. So right now we're thinking that it is when we say that it's a symmetric histogram, but because we don't have enough data and it looks kind of funny, we're not positive if it is or not. So make sure that your data list is L1, and our data axis, meaning the data that we have, remember it always goes on the X. And I'm just going to mark them with these circles. You can choose whatever one you want. There's little dots, there's little plus signs, or there's these square things. So I'm going to choose these square things. So then I hit graph. And so as you can see, to decide whether it actually is a normal probability, we want this to be as much of a straight line as possible. So this is really, really, really linear, right? This is a straight line. So we call that's a really linear model. That's a good thing. The only problems that we see is that I have one outlier that's really, really small, another outlier that's really, really big. So we have one really small shark, one really big shark. Other than that, they're all pretty much straight in this line, which actually shows us that it is actually a normal distribution. So this would be your normal probability model, your graph for this. And you would say that it is, this tells us, because it's in a straight line, that it is actually a normal distribution. So, and then you can just literally, it's way easier to just take a picture of your calculator and put that into a Word document rather than trying to graph all those points. But totally up to you. You can do that if you'd like. All right. Okay, so that's that part. And then the last part is D. And D says, having inspected the data from several different perspectives, do you think that these data are approximately normal? So we would say yes, because they follow the 68, 95, 97 rule, because we plotted the normal probability plot and it's linear, that all of these things together combined tells us that this is approximately a normal distribution of the data. All right, so I hope that that helps with some of the stuff that we're doing for this week. And if you have any questions, let me know.